Okay, so today we talked about creating functions, okay, by putting some functions together. So the four main ways that we talked about putting functions together would be take two functions, say example for f of x and g of x, and saying, I'm going to add them together. So if you see it says take f plus g of x, well, that means you take f of x, which is 3x, the right side of the equation, and you take g of x, which is 2x minus 4, and you're going to plus them together. Okay, do you see how they took both of these functions and they plussed them together to get a new superfunction? And so you could form new functions by subtracting f and g. So you write f and you put a subtraction sign and you put g here. And then you distribute this and combine like terms, and you're going to get a new superfunction by taking f of x minus g of x. Excuse me, as I shift to my chair. Here we go. So f times g of x is going to be we take f of x times g of x and you find that new answer. And then f of x over g of x is going to become a fraction. And so with each of these, they're going to be new functions that you could plug in x values and find y. You could graph them. They could talk about your domain and range. You could find a max of them, all sorts of crazy things. But I think you've got to give a warning instruction. Okay, on the fraction one, the fraction, you've got to say, well, there's a warning. Okay, so if you buy a new appliance, they're going to be like, maybe don't submerge your blender, in a tub of water. That'll wreck it. So they give you a warning. Well, on the fraction ones, that's the one where you have to limit the domain and say, hey, guess what? Don't plug in values for x that make the denominator equals 0. And so you have to give a warning. So you'll see a domain restriction here on the fraction one. It says, hey, don't let x be 2. Why? Well, if you can't have a denominator being 0, if x was 2 on the bottom, you do 2 times 2, which is 4 minus 4, which would be 0 on the bottom. So they just say, hey, just a note, don't put x equals 2 in this problem. Okay, the other ones, the domain is any real number. Okay, they're just polynomials. You can plug in anything you want. But on the fraction ones, you've got to give some domain restrictions. Okay, so we're going to do some problems together. So given these two functions here, okay, given f of x is this one here, and they say given g of x is this one right here, they're saying, can you do f plus g of x? Well, what do you mean? Well, that means take f of x, that function, and then g of x together, and we're going to plus them. So if f of x is going to be 6x squared minus x minus 12, and g of x, we're going to plus g of x, and g of x is 6x plus 2, we're going to say, all right, our new function for f plus g of x, okay, in terms of x, just like f of x means a function in terms of x, x plus f plus g of x is equal to, combining like terms of these equations above, would give you, I copied this wrong. This is 4x. I don't know what I did. Rewind the ship. Okay, function f I didn't write correctly. Function f is 4x squared plus 3x, and then minus 1. So if you combine the terms, you're going to get 4x squared, and then plus 9x, and then plus 1. Now, this is a parabola, right? So its domain is going to be all real numbers. So you write that as negative infinity to a positive infinity. The range, however, on a parabola is going to have a lowest or highest point. So if you graph this on your graphing calculator, you will see that it's a happy parabola, okay? And you can find the lowest point. Second, calculate min and find that lowest point. The y values, the range is going to be from, the lowest point of this is going to be from negative, let's see what it's going to be, negative 4.06 to infinity. Okay, so I wrote a little note up here on the side. Okay, if you've got an odd powered polynomial, the end behavior is going to be either all going uphill or all going downhill. Okay, and so the domain and range will both be all real numbers for odd degree functions. For even ones, you're going to need to use your graphing calculator because there's going to be a lowest point or a highest point. And remember, the range is from the lowest to the highest value. And so, remember, odd are pretty easy. You can just write all reals for both domain and range. And so as we're building these, you may or may not need to do the domain and range. And so just kind of read the directions and see what they say. This next one says do f subtract g of x. Okay, so we're going to write f of x, and we're going to minus off from it g of x, and we're going to get our resultant function because of that. So if f of x is 4x squared plus 3x and then minus 1, and then g of x is going to be 6x plus 2, then if you subtract those from each other, again, distribute the negative to the second parentheses, our new function, and I'm just going to write up here, f minus g of x is going to give us 4x squared, and then it's going to be minus 3x, combine like terms, and then minus 3. And again, it's a lovely odd polynomial. So the domain, or even, I wish it was odd. So the domain is negative infinity to a positive infinity. And then the range, you've got to use your graphing calculator. And it will be a parabola-looking shape. And the lowest y value is going to be negative 3.56 to infinity. So remember, domain is left to right, range is from lowest to highest. And so as we're building this, we can answer that question as well. And the one below here says, okay, f g of x. And they may put a dot. So f times g of x. So you just take f of x and g of x and multiply them together. So we've moved to two new functions, which is fine. You've got f of x is this guy here. And I used it on my first question by mistake. But f of x and g of x, and we're going to multiply those together. And so if you take f times g, f is 6x squared minus x minus 12, and you multiply that by 2x minus 3. And if you multiply that out, okay, we're going to get 12x cubed, and then we're going to get minus 2x squared minus 24x, and then minus 18x squared plus 3x and plus 36. So f times g of x is going to be 12x cubed, I'm going to just put up here, minus 24x. Oh, lies. Okay, rewind the ship. Let me get rid of that. Okay. What is this going to be? Minus 20x squared. And then it's going to be minus 21x. And then plus 36. And so I think the big thing to say about this is that, it's odd, okay? And it's going to be going uphill. It's going to look like this. So the domain and range are both going to be negative infinity to positive infinity. Okay? All right. Now, f over g of x. Now, there is a way to do domain and range on the fractions. We're not going to do that. We're just going to focus on domain restrictions on the fractions. Okay, we will do a chapter about fractions where we talk about domain and range a little bit, but it's kind of the most tricky part to find it. And so we're going to say the domain is going to be, restrictions will be what we focus on. So put f of x, which is 6x squared minus x minus 12 over 2x minus 3. And so that's going to be our answer. Okay. And the domain restrictions, again, on the fractions, we have to tell them, hey, don't put your blender, submerge it. Don't put your phone, don't eat your phone. You're like, don't plug in X's, certain things. Because if you put this in your calculator and you looked at the table of values, there would be one value for X that would have an error as a result. Why? Because when you plug in this value for X, it makes it divide by 0. So to find it, you set the denominator equal to 0 to be like, okay, tell me what I can't do, and then I'll avoid it. So if you solve this equation by adding 3 to both sides and divided by 2, you get x is equal to 1.5. So that means do not plug in 1.5, okay? So that's your domain restrictions. Again, we're going to skip the domain and range, but we'll just say, hey, the domain is anything except for 1.5. Why? Because when you put that into the fraction, you end up with a denominator of 0. Okay, so that's pretty much what we learned on day 1. On day 2, actually I lied. We did go a little further. So let's keep going. We are going to be talking about f of g of x. Okay, see that donut there? It's kind of weird, and I'll tell you where it comes from and kind of what we're going to do with it. Okay, so you've done, if f of x is equal to, say, 2x squared plus 1. Okay, I may have asked you to say do f of 3. That means take function f, plug in 3 for x, and see what you get as an answer. So if 3 is your input, what would be the output? So you square the 3 and then times it by 2. 3 squared is 9 times 2 is 18 plus 1 should be 19. Okay, so you've done that. You also have done f of, say, x plus 1. What do you mean? Take function f and plug in place of x, x plus 1. What do you mean? Well, in place of x, what do you put? X plus 1. And I've asked you guys to simplify that. Remember, you square the binomial. You take x plus 1 times x plus 1, and you multiply them together. I'm going to do this in my head. You get x squared plus 2x plus 1. If you FOIL it out, and you distribute the 2, and then you add 1 to it. So I'm not going to follow that up, but that's what you've done when you've done f of 3, and that's what you've done when you've done f of, say, x plus 1. You plug in that value for x. Well, today, we're going to do kind of bring that together, okay? And so I'm going to shift this, I think. There you go. Okay, so we want to say, if you're doing f of g of x, okay, that means that you start close to the x. You say, okay, I'm going to take function f and I'm going to plug into it g of x. What do you mean? Well, let's start here. G of x is x minus 5. Okay, that's what that is. Substitution, g of x is x minus 5. I'm going to take that and put that into f of that. So instead of doing, like, say, f of 2, we're going to do f plugging in g of x into it, okay, which is just kind of a big handful, but it's what we're going to do, okay? Take the one closest to the x and put it into this f right here, okay? Watch it. So if g of x is x minus 5, we're going to put g of x into f, and so we'll say, okay, f is this big one up here. And so we're going to say, okay, how do I do that? We're going to take x minus 5 in place of x, and we're going to square it, and then minus 3, and we're going to do x minus 5. And they're going to add 2, okay? And so to square a binomial, remember you write it twice and multiply it out. And you get x squared. I'm going to do this in my head. Minus 5x minus 5x, so that's minus 10x. And then negative 5 times negative 5 is 25. And you distribute the negative 3, so you get minus 3x plus 15 and then plus 2. So your answer to this question is going to be f of g of x is equal to, combining like terms, x squared minus 13x, and then plus 42. The domain would be all real numbers. The range, you'd have to use your graphing calculator to find the lowest or highest point. I believe the lowest point is negative 0.25 up to infinity. So that's f of g of x. So the donut means of, okay, because of is such a long word, okay? And so it's like Lake of the Ozarks. They abbreviate the word of and they put an apostrophe. So f of x means f plugging in x. So take f of x and we're going to put that into g of x. So take f of x, which is x squared minus 3x, and then plus 2, and we're going to put that into g. Okay, so we're putting that entire f of x into g. You always put the one closest to x into the one that's outside of it. And these are synonyms. I want you to kind of look at this. We'll do this a little bit on the next page. And so taking this trinomial and put it into g, okay, g is this one right here. So you're going to do x squared minus 3x plus 2, and we're going to minus 5 from it. So our answer, when we combine like terms to this right here, is going to be x squared minus 3x minus 3. Okay, so that's going to be our answer. The last one is g of x. Well, what do you mean by that? We'll take g of x. What's g of x? That's x minus 5. What are you going to do out of the x minus 5? You're going to put that in place of x back into g again. Okay, so look at g. And so we're going to take g of x, which is this bottom function, and we're going to plug in x minus 5. And you're going to do that in place of x, and then you'll subtract 5 again. So this answer is going to be x minus 10. And that's a line. And so domain and range will be all real numbers because it's an odd powered function. So it's kind of weird to be making these new functions. And the way you make them would be like either adding two functions or subtracting two functions or multiplying two functions or dividing two functions or literally plugging in one function into the other in place of x. So I had my kids practice this and say, all right, let's take g of x and put it into f. Okay, so g of x is x plus 5. And we're going to put that right into function f, where instead of doing f of a number, we're going to do f using x plus 5 as the input. So we're going to do 2, and when you see x, we're going to go up to the top equation, 2, and then x plus 5, and then subtract 5. So you distribute and combine like terms. You get 2x plus 5 is equal to f of g of x. Okay, and so any of the functions we write in terms of x are going to have x on the right side of the equation. You could graph them. The domain and range are going to be all real numbers on this because it's a line. Okay, it's going to go forever left and right and forever up and down. G of f of x, okay, f of x goes first. You take f of x, which is 2x minus 5. You're going to put it into g. G is the bottom equation, so you're going to take 2x minus 5 and put it in place of x, and then you'll plus 5. You get 2x plus, minus 5. Okay, so it's just equal to 2x. This equals just 2x. And then again, the domain and range will be all real numbers. And most of the time, f of g of x is not the same as g of f of x. And I told my class, I was like, it's kind of silly. It's kind of like, have you ever eaten shark? Okay, so you taking in a shark is one thing. But you may or may not remember if you've ever eaten shark, but you would definitely remember if a shark ate you. Right here. And so the thing is, the order a lot of times is different. Okay, if you do g of f of x and f of g of x, they probably won't give you the same answer. There are times, and we'll learn about that on Monday, but okay, f of g of x. See this right here? F of g of x means the same as f of g of x. So these are the same. G of f of x, gof of x, and g of f of x, they mean the same thing. Because remember when you say f of 2 is this, or f of x is this. So the of is kind of part of what you say, means f, the function plugging in this number or this letter or this function into it. So f of g of x means take function f and plug into it g of x, which is 2x minus 1. So function f needs that plugged into it. So function f gets that value plugged in for all the x's. So you do 3, and you do 2x minus 1, and you square it, minus, and then 2x minus 1, and then plus 4. And so we've got to square this binomial. You've got to write it twice. So you do 2x minus 1 twice. And do this in my head, you get 4x squared minus 4x, and then plus 1. And then we've got to distribute a 3. And then you have to distribute this negative sign. So you get minus 2x plus 1, and then plus 4. If you distribute the 3 and then combine like terms, your answer is going to be f of g of x. Let me turn my page, make sure I get this correct. We've got 12x squared minus 14x, and then plus 8. Okay, so that's f of g of x. And I could write it FOG, fog of x, or f of g of x. Either those are synonyms, okay? And the domain of this problem would be all real numbers. The range you'd have to calculate using your graphing calculator or finding the vertex. So to find g of f of x, we're going to do, if f of x is 3x squared minus x minus 4, g of 3x squared minus x plus 4. Take that and put it into g. You're going to do 2 times this. Okay, and then we're going to minus 1. So distribute, combine like terms, and then minus 1. Your answer to this question is going to be 6x squared minus 2x, and then plus 7. Okay, so notice f of g of x and g of f of x is not the same thing on most questions. Okay, and so the next thing we'll do is we're going to do this for specific values. See how it says evaluating functions for specific values. So f of g of x, our answer is an equation in terms of x. F of g of 2 or f minus g of 2 is going to be numerical because they're saying, can you take those two functions subtracted using 2 as the input? And so the best way to do it when you're just looking for a specific number is just to do f of 2 minus g of 2. And so what do you mean f of 2? So go up to function f and plug in 2. So you do 2 times 2 and then minus 3. So that's 1. And then do g of 2. Well, that's taking 2 squared. That's 4. And we have to bring down the subtraction sign. Okay, so that gives you negative 3. Okay, so f minus g of 2 is negative 3. And so f times g of 3, if you're going to add, subtract, multiply, or divide, given a certain number, you do f of that number and g of that number, and then do the operation afterwards. So we're going to do f of 3 and then times g of 3. Okay, we'll multiply those results. So f of 3 is 2 times 3 minus 3. So that's 6, that's 3. G of 3 is just 3 squared, which is 9. So that'll give us equals 27. I do want you to write that whole left side equals 27. So a lot of times I just kind of go up to the original problem and be like, equals 27, equals what? So, so that it looks complete. So it's an equation of a pretty answer. So f of negative 2 over g of negative 2. So f of negative 2 is going to give us negative 4 minus 3. That's negative 7 over g of negative 2, which is 4. So this is negative 7 over 4. And then the last one says do f of 5 plus g of 5. Okay, and so f of 5 and g of 5 plus together. F of 5 is 7, it looks like, and G of 5 is 25, and you get 32 as an answer. Okay, so that's kind of cute. For add, subtract, multiply, and divide, you just evaluate each item and then do the operation that is required. Now, for these guys, F of G of X, you've got to do like a substitute in, and then you take that answer and substitute in the other one. So evaluate the function, and then plug it into that result into the other function. What do you mean? Well, do the one that's closest to the number. Okay, my directions don't make the most sense. So do G of 3. What do you mean? Take function G, plug in 3, see what you get. Okay, put your result below it. So G of 3 says take, that's the second equation. So you're going to take 3 squared, you get 9. And then we have to plug that result into F, okay, as the input into F. Okay, so you plug in the original input into the original function, get your answer, and then plug that result as an input into the other function. And so we're going to say do F of 9. So that's going to be 2 times 9, and then minus 3. That's 18 minus 3 is 15. So this answer is 15. G of F of 3, we'll do F of 3. Okay, look at function F, which is the first one. So you do 2 times 3 and minus 3. That's 6 minus 3. That's going to be 3. Now we've got to bring down the G. Do G of 3. Well, G of 3 means take 3 squared. Oh, that's 9. Okay, so your second answer will be 9. So F of 2, the brackets, just mean kind of fancy parentheses. So do F of 2, okay? See what you get as an answer. F of 2 would be 2 times 2 and minus 3. That's 4 minus 3 is 1. And then you take that result and plug it into F again. So that result is your new input. So you plug in 1 to F, and you go 2 times 1, and then you minus 3. That's negative 1. So your final answer is negative 1. And the last one's in terms of 3a. So your answer is going to be in terms of a. So you do G of a. I'm going to scooch this over because I'm going to need a little room. So do G of a, 3a. And so G of 3a says square it. So you take 3a and you square it. Well, 3a times 3a is going to be 9a squared. And you're going to plug that into F, okay? And so if you plug that into F, okay, you're going to do 2 times that. And then you're going to minus 3. And so that's 18a squared and then minus 3. So that's your answer. You could put it right after that. So evaluating these, if it's add, subtract, multiply, divide, evaluate each item and then add them or subtract, multiply, divide. If it's F of G of X, you've got to evaluate the closest one to the number, take that result, plug it into the outer function, okay, as far as you need to go. The next ones seem harder, but they're actually easier. So that's kind of cute. So watch this. So on this table, the x's are the inputs, and then the results of plugging that input into F of X goes in the second row. The results of plugging in these x's on the top row into G of X is in the bottom row. So if I want to find out F plus G of 4, again, I want to do F of 4, and I want to do G of 4, and I want to plus them together. So if I input 4 to F, I will get 5 as an answer. If I input 4 into G, I will get 3 as an answer. And then you've got to add them together. So you get 8 as a result of this first question. So if you want to do F of 1, subtract off G of 1. Okay. So F of 1 gives you 3 minus G of 1. G of 1 is negative 2. So you have to minus off a negative 2. You get 5. Okay. So F times G of negative. So let's do F of negative 2 times G of negative 2. So F of negative 2 and G of negative 2, so that's 4 and 6. That's 24. Okay. G of 3, okay, over F of 3. So G of 3 is going to give you negative, let's see what that is, 4, okay, over negative 2. And you're going to get negative 2 as your answer. Now, here's where you got to be a little snipey. No, you don't do F of 4 and G of 4 and then time. No. This is F of G of 4. That means you start and evaluate G of 4. So G of 4, okay, I can switch colors. G of 4. So if you plug in G is 4 and you get the result from G is going to be 3. Now I have to plug 3 as an input into F and see what happens, okay? So you take 3 and you put it into F and you get negative 2. So the input's on the top and the result is on the bottom. So F of G of 4 means evaluate 4 as an input, get 3 as an answer. Take that 3 as an answer and plug that as an input into F to find out your resultant answer is -2. Okay, G of -2, and that's going to give us, let's see, 6, okay. And then you got F of 6. You're like, oh, I don't know what to do. Well, the thing is this, it's not defined. Okay, they didn't tell us what's going to happen with that. Like with an equation, you can plug it in. But with this, like what happens if you plug in 6 into F? We don't know. Okay, it's not defined. And so you write not defined. The other ones, the only ones that are defined are when X is -2, 1, 3, and 4. The other ones, you could speculate, but that's not what we're looking to do. We're trying to say, what is actually there. Okay, the last ones appear more difficult, but again, function F and the example points are in the top row. G of X and their example points are in the second row. Remember, when we're talking about points, the input is X, the output is Y. Okay, so this says do G of 8. That means plug in X is 8 and see what you get into G. So if you look at X is 8, your output for X is 8 is 2. And then we have to plug in 2 into F to see what we get is our final output. So look at row F. Oh, if I plug in X is 2, I get 6 as an answer. So my final answer is 6. Doing G of -1, I can switch colors. Plugging in G is -1. Okay, into G, if X is -1, then the result is 7. Let's do F of 7. Okay, if you plug in 7, oh, it looks like we get 7 as an answer. So your final answer to this is 7. So again, once you do the first function, that output is the new input to the secondary function. So let's do F of 2. If you plug in X is 2 to F, you get 6 as an answer. And then they want to plug that into F again. Okay. Oh, you get -1. Okay. So your final answer is going to be -1. Okay. The last one, F of 4. I don't see that. Okay. I have no idea. If you plug in F as 4, I don't know what you get for an answer. You're right. Not defined. All right. So we are writing new functions, and then we're going to use like some facts or some equations or some example questions to say, okay, well, what would be F of G of 4? Or what would be F plus G of 4? What would be those numerical values? So if you're writing an equation, it's going to be in terms of X. If you're evaluating numerically, you're going to get an answer. All right. Thank you. Have a good day.